Hello guys, welcome to this lesson. In our previous lesson, we focused on the classification of data structures, and in this series of lessons, we are going to be focusing on the primitive data structures. And we know that primitive data structures in our previous lesson were the simplest forms of data structures. And primitive data structures are manipulated by the machine instructions directly. So let's ride on. In our lesson plan, we are going to have the real life situation, we have an introduction, we have a lesson content, we have conclusion, then we have a practice exercise or assignment. Okay, now in our real life situation, we have Kelly is a student in Tanshi Academy. She's passionate about programming and how computers work. She's wondering how basic operations such as addition, subtraction can be done in a computer system. But first, the computer needs to store the integer before operations can be done on it. She therefore needs to understand what kind of data structure is needed to keep a number and characters. The notions of primitive data type is needed for this problem. So that is a problem situation. And we have a student who is wondering how basic operations can be done on integers in a computer system and maybe how they can be stored. So let's ride on. Okay, now we are going to look at primitive data structures. Primitive data structures are the most basic forms of data structure that directly operate upon the machine instructions. I love the way it is framed here because it says it is the most basic form of data structure that directly operates upon the machine instructions. Now they are built into the programming languages and serves as a fundamental building blocks for more complex. So my dear students, what you should understand is primitive data structures are manipulated by the machine instructions directly, and they can form the basis of developing a complex data structure. So the types of primitive data structures available can vary depending on the programming language. So as you see, when we'll be doing our practical phase of these modules, we are going to be seeing that, well, because we'll be mostly implementing using C programming, we'll see that the primitive data types vary. When you're using Python or any other language, or maybe Java, the data types primitive are different, and there are some that have more primitive than others. Okay, now let's proceed. Types of primitive data structures. The first primitive data structure is an integer. An integer is a positive or a negative whole number, including 0. So for example, if you want to store an integer in a computer system, you can store either a positive or a negative whole number. As you can see the representation, we have -10, we have 0, we have 25. So that is an integer. So an integer is a positive or a negative whole number. Now we have floating point numbers. Floating point numbers are used to represent real numbers with decimal points, for example, such as 3.14 or -0.001. So that is the second type of primitive data structure. The third is character. It stores individual characters, such as we have A, maybe Z, we have a special character. The @ symbol typically requires a single byte of memory. And the fourth is Boolean, that represent truth values with two states, true or false. So basically, these are the different types of primitive data structures used in a computer system. Okay, now usage of primitive data structures. Where are they used? Integers. Integers are used when performing arithmetic operations that don't require fractional values. For example, addition, multiplication, subtraction. Okay, we can use integers. So integers are used when you want to perform arithmetic operations. The next form of data structure where it is used, floating point numbers. Let's look at where floating point numbers are used. They are essentials in fields like scientific computation, where precision with decimals is crucial. So for example, we are carrying out statistics that require decimal values, or you are doing computation that requires decimal values, you can use floating point numbers. Characters. They form the basis of strings. We should remember that a string is a combination of characters. So if you want to spell out a name, for example, just the name characters is a combination of characters, or primitive is a combination of characters. So P is a character, R is a character. When you combine all of them, it forms a string. So characters form the basis of strings. Then we have booleans. They play a critical role in control flow decisions within programs. For example, they'll say if your average is greater than 10, yes, you have passed. Less than 10, you have failed. So there are two options, either yes or no. And like loops and conditional statement make use of booleans. Okay, so those are the possible areas where primitive data structures can be used. Importance of primitive data structures. Why are they important? Understanding this type is essential because they form the foundation upon which all other abstract structures like arrays, etc., depend to function correctly and efficiently. So, which means that primitive data structures form a foundation for complex data structures. So, if you want to build non-primitive data structures, you have to understand primitive data structures. Second, each programming language has specific rules regarding how these primitives can be used and what operations can be performed on them. So you see that it is important because you will need to understand that different programming languages have different ways they can be manipulated. So it is important to understand primitive data structures based on the language too. And therefore, it is important to refer to specific language documentation for detailed behavior, such as size, limit, when handling mechanisms. So you see that when dealing with primitive data structures in C programming, it might not be the same in Python or in Pascal. So, but the whole concept is going to be the same because you are going to be dealing with same category of data structures. So it is important for students to know the importance of primitive data structures. One, it helps you build complex data structures. And of course, it helps you perform basic operations in a computer system. Conclusion. In summary, an integer represents whole numbers, both positive and negative. A floating point number is used to represent real numbers with decimal points, such as 3.14 or minus 0.001. Characters, they store individual characters such as A, Z, or any other character. Special symbols typically requires a single byte of memory. And of course, a boolean represents truth values with two states, true or false. So this is in summary primitive data type. Now, this phase of the training is our theory phase. At the level of the practicals, we are going to now see how we can declare and store values in primitive form. Like how do we declare, use an integer, how do we declare floating point numbers, how we declare characters, and how do we declare booleans in programming. So, for revision question, my dear students, to have insights of this lesson, the first question is for you to define a primitive data structure, explain the different types of primitive data structures, and describe the usage of primitive data structures. And lastly, explain the importance of primitive data structures. So after having gone through this lesson, for you to actually show that you have understood the lesson, try to answer these questions and get set to the next lesson. In our next lesson, we are going to be focusing on non-primitive data structures. We are going to look at linear and non-linear data structures. So stay put and wait for the next lesson. Thank you.